All right, let's talk about enterprise AI. We're going to look past that simple chat window you see on the screen and dive deep into the massive hidden world that actually makes it all work. Let's get right into it.
You know the experience, right? You type a question into a chat box, and boom, a super helpful answer pops up almost instantly. It feels like magic. But have you ever stopped to wonder what's really going on behind that screen? What kind of engine is driving that simple little conversation?
Well, probably the best way to think about it is with this AI application iceberg. That clean, simple interface you interact with, that's just the tip. It's only about 10% of the whole story. The other 90%, well, that's this giant hidden world of complexity sitting right below the surface.
So, let's do it. Let's take a quick dive and explore what's hiding below the waterline. We're going to move pretty fast here, but I promise this will give you a real sense of the sheer scale of engineering it takes to make that simple AI actually work. Okay, first up, just below the surface, you have the user interface layer. And this is way more than just the buttons you see. It's about prompt engineering, which is basically the art of asking the AI questions in the best possible way. It's also about formatting the AI's answers so they make sense, and managing the whole conversation so the AI remembers what you've been talking about.
Go a little deeper and you hit the AI model layer. This is where the big decision gets made. Which brain are we going to use for this job? Is it a GPT model, Claude, Llama? And it's not just picking one. You have to manage its short-term memory, things like tokens and context windows, to make sure it has just enough info to be helpful without getting slow or confused.
Next up is the orchestration layer. Now, you can think of this as the air traffic controller for the whole operation. It coordinates lots of different AI agents, manages the system's memory, and decides exactly which tool or which database to tap into for your specific question. This is where the real problem-solving magic happened.
Okay, now we're getting deep. Down here is the foundation, the data systems and the infrastructure. This is all the heavy machinery. We're talking specialized vector databases so the AI can find info fast, powerful GPUs that provide the raw computing horsepower, and really complex systems like Kubernetes to manage all the moving parts and make sure it can handle thousands of users at once.
Now, what's really interesting is that woven through all of these layers are security and observability. And these are totally non-negotiable. This is all about protecting private user data, complying with laws like GDPR, and just constantly keeping an eye on the system for errors or performance dips.
And finally, at the very bottom, you have the layers that make it truly ready for the big leagues. This is stuff like integrating with other companies' software, managing the model's entire lifecycle, what the pros call MLOps, and crucially, putting in safety checks to prevent things like AI hallucinations, which is when the model just kind of makes things up. So when you add up all those hidden layers, all those different pieces, what are we talking about? Somewhere between 50 and over 200 individual components. That is an incredible amount of complexity to build, connect, and maintain, all just to make one simple AI app work. So how in the world do you tame all that complexity? I mean, you can't just throw 200 things together and cross your fingers. You need a plan. You need a structured, layer-by-layer approach. And this is where the idea of a sovereign AI stack comes into play. It's about building a platform that gives you total control over everything.
It all starts at the very bottom, at layer 1, the bedrock. This is the physical foundation. We're talking about servers packed with powerful GPUs, super fast networking, and tons of storage, all designed to work together perfectly. This layer provides all the raw horsepower for everything else we're going to build on top.
Now, on top of all that powerful hardware, you need a brain to manage it all. That's layer 2, the orchestration layer, where something like Red Hat OpenShift comes in. Think of it as the master operating system for your AI factory, making sure everything runs smoothly, securely, and can scale up when you need it to.
Moving up to layer 3, this is where your data scientists and engineers get to work. It's the AI/MLOps platform. A tool like OpenShift AI gives them the whole workshop. Everything they need to experiment, build, train, and deploy their AI models in a really controlled and repeatable way.
Remember how important security was in our iceberg? Well, here in layer 4, you can see how it's not just an afterthought, it's a core part of the design. A dedicated security fabric like Cisco AI Defense is literally woven right into the stack. It's constantly on guard, protecting against AI-specific attacks like people trying to trick the model or steal your data.
And finally, to get that lightning-fast, real-time feeling for the user, you need layer 5, high-performance serving.
This is handled by a specialized engine, like vLLM, which is designed to run these huge language models with maximum speed and efficiency. This is the layer that makes the AI feel instant.
Okay, so we've gone through the trouble of building this incredibly powerful, secure, and, yes, complex stack. But what for? What's the payoff? Let's take a look at the amazing things you can actually build on top of this rock-solid foundation.
For starters, you can finally unlock your own company's data. Imagine an app where any employee can just ask questions in plain English. Talk to my data lets them literally have a conversation with reports and documents. And Talk to my database lets them pull info from complex data systems without having to write a single line of code. Pretty cool, right?
The payoff is also huge for automation. An app for document intelligence can automatically read invoices or contracts and pull out all the important info, saving people just countless hours of boring work. Or you could build specialized AI bots for HR or IT, giving employees instant, secure answers to their most common questions.
So we've gone from this massive hidden complexity to a structured, layered stack, all the way to real-world applications. But the final and maybe most critical piece of this whole puzzle is getting from all that complexity to having complete control. It's all about trusting that your AI is secure, validated, and actually ready for business. And this is what that control looks like in the real world. You can run what are called red team exercises, where you basically try to attack your own AI. So here, someone's trying a malicious prompt to get the model to leak salary data. But look, the security layer, Cisco AI Defense, catches it, blocks it, and sends up an alert. The threat is stopped dead in its tracks before it ever even reaches the AI model.
Ultimately, getting to that production-ready state means you can confidently go down this list and check every single box. Are our expensive GPUs actually being used to their full potential? Is our security shield active? Are our models validated? Are the audit logs turned on? Is our backup and disaster recovery plan ready to go? Only when you can say yes to all of this are you truly enterprise ready.
And this kind of brings us full circle, doesn't it? This quote just nails it. The simpler it looks on top, the more sophisticated it is underneath. The whole point of taming all this insane complexity is to create an experience so seamless, so effortless, that your users never, ever have to know what's going on under the hood.
So, I'll leave you with this one question to think about for your own work. Your AI application might look simple on the outside, but do you really have control of what's happening in that 90% underneath? Because that hidden part, that's what makes all the difference. Thanks for joining us for this explanation.